Hi, welcome to part 14 of the video series about work and energy. In the previous video, we learned how to calculate the work done by non-conservative forces. In this video, we are going to extend our knowledge about power. As you know from grade 10, power is the rate at which work is done or the rate at which energy is transferred to or from a system. According to physics, the most powerful person is the one who is doing the work fastest. Formula of power is work divided by time. Sometimes we can write it as energy transferred divided by time as well. As work and time both are scalar quantities, so is power. And the unit of power is watt, which is denoted as W. Till this point, we just revisited the topic power from grade 10. Now, let's imagine a vehicle moving at a constant speed. The force which causes it to move is the force of engine. Our task is to calculate the power of the engine if the force F and speed of the vehicle are already known. The only formula we know how to calculate power is the one on the top of the screen. Power is equal to work done on an object divided by the time. The problem is that none of them are given. So let's try to alter the formula. Work is equal to force multiplied by displacement multiplied by cosine theta. In the given case, force and the displacement are in the same direction, which means the angle between the two is 0. As we know, cosine 0 is equal to 1. Therefore, we can simplify the formula as force times displacement over time. Once more, we have to refresh our knowledge of grade 10 physics class to recall that displacement over time is equal to the velocity of an object. By replacing expression of delta x over t with velocity, we can get new formula to calculate power. Power is equal to the product of a force applied on an object and the velocity of the object. Using this formula, we can easily calculate the power of a vehicle if force of the engine and velocity of the vehicle will be provided in the question. Let's solve a couple of examples to understand it better. Calculate the power delivered by a force of 10 newtons which is required to move a 10 kg box at a constant speed of 1 meter per second over a rough surface. We can notice that both work done on an object and time are missing in the question. So we try to use the new formula. Power is equal to force times velocity. Force is 10 newtons and the velocity is 1 meters per second. Power delivered by the force is 10 watts. In a more complicated question, an escalator is used to move 20 passengers every minute from the first floor of a shopping mall to the second. The second floor is located 5 meters above the first floor. The average passenger's mass is 70 kgs. Determine the power requirement of the escalator in order to move this number of passengers in this amount of time. We can solve this question by using both formulas of power. In option 1, we are going to use the formula power is equal to force times velocity. Both force and velocity are unknown, hence let's calculate them. An escalator is trying to overcome the force of gravity, which is equal to mass times gravitational acceleration. It can lift up to 20 persons of mass 70 kgs each. Force of gravity will be equal to 20 times 70 multiplied by 9.8 meters per second square. The result is 13,720 newtons. Velocity of an object is equal to the ratio of the displacement and the time. Displacement is 5 meters and the time is 1 minute, which is equal to 60 seconds. Velocity of the escalator is 0.833 meters per second. Now that we know the force and the velocity, we can calculate the power of the escalator. 13,720 times 0.833 is equal to 1,143,33 watts. Now let's solve the question by using the formula power is equal to work over time. Work itself is equal to force times displacement times cosine theta. As escalator is doing work against gravity, its magnitude is equal to the force of gravity. Mass is 20 times 70, gravitation acceleration is 9.8 meters per second square, displacement is 5 meters, and the angle is equal to 0. As escalator tries to lift people up, and the direction of the displacement is upwards as well. Time is equal to 60 seconds. Power is equal to 1143,33 watts. In this video, we have extended our knowledge of power. This was the last topic in this chapter. In the next video, we are going to start to solve some extra questions related to this chapter. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.